In our last lesson, we talked about scatter plots and how scatter plots show these positive relationships, negative relationships, or no relationship, where our points are not necessarily nice, perfectly straight lines. So we can certainly see trends in that information, but we're definitely estimating information and not getting exact numbers. So in this lesson, we're going to talk about something called a line of fit. So a line of fit is a line that is drawn on a scatter plot close to most of the data points. And that's important to notice. We're not just going to connect the points. We're not just going to hit every point, but we're basically going to try to get as close to most of the points as possible. And then we're going to use that line, which is nice and straight, to estimate data on that graph. So first, we got to go back to what we talked about in our scatter plots. So first, finding a line of fit. The table below shows the number of absences in a school year and the final exam for several students. So what we first want to do is make a scatter plot, and then we'll talk about drawing the line of fit. So as a refresher from the scatter plots, and then you're going to go ahead and plot these on your own. The absences are our x. So definitely on our graph, we want to label what the x-axis stands for. It's the number of absences. So then we want to label what the y's stand for. Okay? And then we talked about how do we figure out some scales. We don't have to have the same scale. So in this one, when I look at my x's, I'm pretty sure if I just go by ones, we'll make it. And then if I look at my exam scores, now here we have something that we're definitely going to show a jump. So we're going to do that break to jump up. Now we have 97 as our high score, which is really good. We also have a 65 as our low point. So our numbers are falling in this 35 to 40 range. So with the idea that we are basically going to be seeing 10 blocks going up on our graph, I need to go up by about 5s. Okay, so let's do this. Let's say our very first score is going to be the 65. So we're going to go from 0 to 65 with that break for that first block. But then after that, we're going to go by 5s every single time. Remember, we said you are okay to jump that first time, but then we have to be on a consistent scale after that. So I'm going to pause the video. I want you to plot these numbers in the table, and then when you think you have it, come back and we'll see if we have the same thing. So there is the scatter plot with the data just plotted. Okay, so first thing, it doesn't ask for this, but let's just talk about what kind of relationship are we seeing. Well, as I'm seeing the number of absences climb, we're seeing the score on the final exam dropping. So notice not always, like right here, these two students had 5 absences. One of them got an 83 on the test, and one of them got an 88. That's still pretty good. It's not the exact same thing. So we're not claiming that if you have 5 absences, you're going to get a certain score, because this is real data. Just like over here, there are 2 students that had 9 absences, and one of them got the 65 and one of them got a 70. But overall, you can see the more absences you have, you're going to be typically lowering in your score. Obviously, you're missing information. So then, draw a line of fit. So what is a line of fit? So a line of fit is where we're trying to estimate the data. We definitely want to use a straight edge, and I can't really use one here, so it's hard to show you one exactly. But what we also want to do is we want to try to have a good representation of our data. So I'm going to draw this one. Now, to be a good line of fit, you want to see that you maybe hit a couple of points. Like I tried to hit this point right here because it's a part of our data. I tried to hit this point because it's part of our data. I don't have to hit the first and the last ones. I don't have to hit any certain number of them. I do have to put a perfectly straight line through my data. The other thing you're looking for, as you'll notice, I have a couple below. I have 4 basically below, and I've got 3 above, and actually a 4th one if I don't count this one and I count this one instead. So I kind of have a decent balance here. So a line of fit is trying to create a perfect straight line through a bunch of information that's not straight. But what we want to do is use that to write the equation of our line of fit. So remember, how do I write an equation? So B says to write the equation. So what I would do is think of this form. That's how we can write an equation of the line, like we're writing it from the line. So, a couple of things. The B. So if I look at the B, remember the B is our y-intercept. Well, it kind of looks like my B probably hits 100. So I'm going to go with that. I'm going to say the B is 100. I'm going to leave the y, and I'm going to leave the x. Remember the M. M stands for slope. So here I am going to find 2 points on my line, and I'm going to use that to make the slope. So looking through my points, it kind of looks like I hit this point, and I hit that point, okay, so I can use it. I don't really know that I hit any others, but look at this one right here. It's not one of our data points, but it's definitely on a grid line, and I can use that. So let's look at that information. So if I do my rise over my run, well, the 3 was an 88. So the 388 was the point that I first circled. And then this other point that's not part of our data, but we can clearly see, is 775. So remember, with our rise over my run, what I would do is I would say, subtract your y's, so 88 minus 75, and then subtract in that same direction 3 minus 7. So I would get 13 over negative 4. So my slope, which then filled in to my equation, is negative 13 fourths x plus 100. Not a nice number, definitely not a nice whole number, but it is what it is. It's the best representation that I have for this line of fit that I've drawn. And then question C, this is always the big one. So question C says to interpret the slope and the y-intercept. So remember, interpret, explain using the labels. So the slope. The slope is not negative 13 fourths. It is, but that's not interpreting. Basically, when we talk about the change in the y's, which is my numerator, that is talking about our exam scores. Then remember, our absences are the x, or change in x scores, at the bottom in the denominator. So my slope really, in this case, represents your score drops 13 points per 4 absences. That would be a way to describe and interpret negative 13/4. You also could go a little bit further and you could say this is approximately 3 points per absence. So you can go to 1 absent, or you can go to 13 points out of every 4. And then when I interpret the y-intercept, basically what it says, you expect to get 100 for 0 absences. Okay, so 0 absence gives you the best chance to get that 100. So that's how you would put a line of fit through your data. And then a second one here. So this one has got some interesting things happening here. So notice first that our table, we have a year, which are our x's. Notice we say 0 years, 1 years, 2 years, so we'll look at that in a second. And then our y's are bats in thousands. So I just want you to think about that. So the bats in thousands means that that first one, for example, is not 327, but it's 327,000. So we just got to keep that in mind as we work. So let's go back to what we're being asked to do. So the table is showing the number of bats in a cave each year from 2010 to 2017, where x equals 0 represents the year 2010. So that's important to notice here. So again, just like the 327 was not 327, it was 327,000, 0 is actually the year 2010, 1 is 2011, 2 is 2012, all the way through. So we just got to keep that in mind. So the question is, in what year will there be 65,000 bats in the cage? So basically we're going to be looking and trying to figure out in our table, when is it 65,000? And again, because the table is based in thousands, we're really looking to figure out when is that table going to say 65, not 65,000. So first thing is understand the question. We're given the number of bats in a cave each year from 2010 to 2017. We're asked to predict when there will be 65,000 in the cave. Make a plan. Let's plot the data on a scatter plot, make a line of fit, and find the equation of the line of fit. And then we'll use that equation to solve by plugging in. So let's go back to the first part. Plot the data on a scatter plot and make a line of fit. Okay, so here you'll notice this grid doesn't have any x or y axis. So let's get one of them in there. So we're going to put them here. And again, notice we're not doing a negative quadrant in any way, because you can't have negative years, you can't have negative bats. So we're going to put over here that it's the number of bats, and I'm just going to put 1,000 with an S, so thousands. And then I got to come down a little bit further, and we're going to put the year. Okay, so we already know that we have the years 0 through 7. So let's just keep that for now. Okay, so we're just going to go out to 10. Now, we got to figure out our scale for that other piece. So that's the important part of this one. So looking at our scales. So this one, we can clearly see that it's dropping every year for sure. So we got to get some pretty high numbers up here. All right, so let's just think this out. We kind of would like our graph to show the 65 if we could. That would be helpful. We don't have to, but it would be nice if we could. So our grid here, what do we have? We have more than 10. 1, 2, oh. was a mess all over the place, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 15. So I'm thinking on this one, 15. What if we just went by 25s? It's a little bit tight. Let's just go with 25s, okay? I think if we do the 25, we can get high enough. So let's just try it. If it doesn't work, we can always change it. So there would be 25, there would be 50, 75, and then 100, 125, 150, 200, 225, 250, 300, 350. Now obviously I skipped over some. You can fill them in if you really want to. I just think it's going to be tricky with me on this. You don't have to in some ways, as long as you made sure you skipped and you got those major ones. So let's pause the video. You plot your graph and I'll plot mine. Then we can check on them to see if we did the same thing, and then we can go from there. So there are my points plotted on the graph. Hopefully you have something that's close to this. So this one's a little bit tricky because we have a lot of points really close to each other, so it's not an easy one to kind of do. It seems like it should be easy. We still want to find a balance. So I'm actually, this time, going to try to connect that first point, and again, try to draw something that's as close as possible, covering as many points as I can without just hitting them all. They're not bouncing around, but a nice, perfect straight line the best I can. So with my line of fits, now we have to find that equation. So on this one, I purposely hit that first point, just because we knew what it was, and I kind of wanted to use something that I know for sure. So that very first point is the y-intercept, so that's 327. The x is going to stay there. Then we need to find that m. So again, m stands for the slope, and what we want to look at is trying to find another point or two that we could kind of clearly see and use that to help. Okay, so I don't know for sure. I don't have a perfect straight line in here, but again, just to kind of make sure that you're hearing me on this, I am going to steal this point right there. It is not part of our data, but it is on the line, at least on my line. It might not be exactly on your line, and you have to take points off that are on your line. So that point is 5, 225. Okay, so if I was to take that point, 5, 225, that would be one of the points. This upper point was 0, 327. And if I was trying to find the slope between those two, I could do 327 minus 225 for my rise, which is down 102. And then I could do 0 minus 5 to get negative 5. Now here's a case where it's not exactly 100% correct to do this, but I'm going to actually reduce this a little bit, and I'm going to say that's really close to 100 over 5. So I'm going to kind of do a little bit of clarifying estimating wise and make that negative 20. So I'm going to say that our equation is negative 20x plus 327. That would be our line of fit. Now, to solve, they want to know, when are we going to see 65,000 bats in the cave? So we can try to use the graph. So 65, where would that be? That would be somewhere in this range. That's about 65. But I can't see it hit, can I? So it's kind of hard unless I continued my graph. But I can also use my equation. So 65,000 So let's think about it. The number of bats is my y value. That's right here. So what I can do is I could actually plug in the y as not 65,000 because the table is thousands, 65. And by doing that, now I have the rest of my equation that I can go ahead and just start solving. And then this, again, we keep running into solving equations all year. We're going to do this on both sides. And I get negative 262 equals negative 20x. And when I divide by negative 20, I get x equals 13.1. So then we say, okay, 13.1. So what does x represent? X represents the years, where 0 was 2010, and we're looking at 13 years after 2010. So we can kind of put this into an answer here. Answer is not x is 13.1. Basically, that is saying that it's going to take a little over 13 years to get to 65,000 bats. And more importantly, 13 years would be the year 2023, because that would be 13 years after 2010. Now, does that mean that's going to happen? No. It could be that the bat population goes up, and it could drop dramatically for lots of different reasons. We're using this to predict. So that's what a line of fit is. We try to use it to help predict future events based on data that we have so far. It's important that you try to connect as many points as you can without forcing them. Lay a nice perfect straight line, then use your y equals mx plus b to find your y-intercept, calculate your slope, and then you can use that to calculate answers. Hope this is helpful. Please ask any kind of questions you have when I see you in class.